Assalamu alaikum and good day everyone. So today I'm going to teach you on how to solve homogeneous equation with constant coefficient. So what is homogeneous equation with constant coefficient? What is the general form of this equation? Okay, so you have to know the general form first. Then only you can solve by using this either this one or this one. Okay. So the general form of homogeneous equation with constant coefficient is given by ay double prime plus by prime plus cy is equals to fx. So this is the general form of second order linear differential equation. Okay, now we are going to solve for homogeneous equation, okay, with constant coefficient. So you know that a, b, c are a constant. Okay, so you will have a real value here for a, b, and c. Okay, so when you are involved with homogeneous equation, as I told you in a previous class, homogeneous equation, your fx is equals to 0. So therefore, your second order linear differential equation will become ay double prime plus by prime plus cy is equals to 0. Okay, where your a, b, c are constants. Okay, so when you have this kind of problem, so you are going to solve it by using this one. Okay, so first step is when you are given the linear differential equation, you have to change it. You have to express it in the form of characteristic equation. Okay, so step 1, express the linear equation into characteristic equation, which is given by am squared plus bm plus c is equals to 0. Okay, so you have to change the linear equation here into this characteristic equation. So next you're going to find the roots. Okay, find the value of m. Find the value of m, or the roots of m. Okay, the roots of this one. Okay, so the general solution, sorry, this is number 2. So number 3, you have to find the general solution depending on type of roots that you obtain in step 2. Okay, and the last one, if you have any initial conditions given to you, so if you have any initial condition, apply to obtain the value of the constant. Okay, so for types of root here, we discuss first what is type of roots available. Okay, so types of root. Okay, you will have, I identified as first case, second case, and third case. Okay, case 1, case 2, case 3. Okay, so as for case 1, case 1 where your M1 is not equals to M2. You have two different value of M. Okay? Different value of M. Okay? So your general solution will be y is equals to AEM1x plus BEM2x. Okay, so this is the general form for case 1. Let me highlight it. Okay, this one. Okay, for case 2, where your M1 is equals to M2, which is equal root. Okay, so your general solution will be y is equals to a plus bx emx, since you just have one value of m. So the last one is case 3 when you involve with complex roots. Okay, case 3. So your general for m is given as m is equals to alpha plus minus beta I. Okay, so this is a complex root. Okay, so the general form, the general solution of this case is given as y is equals to exponent alpha x a cos beta x plus b sin beta x. Okay, so these are the three cases. So when you are given homogeneous equation with constant coefficient, so first we change it into characteristic equation and find the value of m and decide either this is case 1, case 2, case 3 depends on the value of m that you have. Okay, so if you are given any initial condition here, so apply to find the value of the constant a and b. Okay, if you remember in chapter 2 when we involved with first order linear differential equation, we end up with one constant. So now when we are dealing with second order linear differential equation, you end up with two constants, a and b. Okay, so next we try to solve a problem for case 1, case 2 and case 3. Okay, so let's consider this one. Sorry. Okay, example 1. Okay, let's consider this linear equation. You have 2y double prime plus 5y prime plus 2y is equals to 0. Okay, so this one here. So this is homogeneous equation. Why? Because this one fx is equals to 0. And this is constant coefficient, as you can see here, 2, 5 and 2. Constant, value of constant. Okay, so to solve the second order linear differential equation, first you have to express the following problem in terms of characteristic equation. So you will have 2m squared plus 5m plus 2 is equals to 0. So next, find the value of m. Okay, so straight away you can use your calculator here So find equation. So mode equation here, first one. Okay, this one is unknown. So and another one is degree. So in this case we are using degree, okay, because you have your m here power 2, so you will use degree 2. Okay, so what is the values? We key in the value of a, b and c. So your a is equals to 2, your b is equals to 5, and your c is equals to 2. So therefore you will have the value of m, where your m1 is equals to negative 1 over 2, and another one is your m2 is equals to negative 2. Okay, so until here, are you clear? Okay, so you just key in this value into your calculator and get the value of m. Okay, so now as you can see here, you have two different value of m. The first one is negative 1 over 2 and the second one is negative 2. So according to what we have just now, this one here, so identify whether this problem, okay, is in case 1, case 2 or case 3. So since you have a different value of m, so therefore this is your general solution. Okay, so we are using this one. Okay, so you will have y, so your solution will become, so number 3, sorry, I'm using another one. So y is equals to aem1x plus bem2x. So substitute the value of m1 and m2 will give you, so your y is equals to ae negative 1 over 2x plus be negative 2x. Okay, so this is your general solution. Okay, this one is your general solution. Okay, so let's consider if you are given an initial condition. Okay, let's say you have y0 is equals to 0. Oops, sorry. Another one is y prime 0 is equals to 1. Okay, so you are given these two conditions here for you to find the value of a and b. Okay, so as you can see now, is the first condition, y0 is equals to 0. So you directly can apply this condition into your general solution. Okay, but the problem is now you have y prime 0. Okay, y prime 0 is equals to 1. This is your another condition. Okay, so before you can use this condition, you have to find what is your y prime. So what you need to do is you have to differentiate your general solution. Okay, so differentiate this one will give you y prime is equals to a, differentiate exponent will give you back exponent e negative 1 over 2x, and you have to differentiate the power here. Okay, negative 1 over 2x will give you negative 1 over 2. Okay, plus b, again the same thing, exponent, differentiate exponent negative 2x, you will have exponent negative 2x, and differentiate negative 2x will give you negative 2. So therefore your y prime is equals to negative 1 over 2a e negative 1 over 2x minus 2b e negative 2x. Okay, so as you can see here, this is your y and this is your y prime. Okay, so now you can apply the condition. Okay, so this one here substitute into the first one and use the second condition into the second equation, this equation. Okay, so the first equation you have is y is equals to a e negative 1 over 2x plus b e negative 2x. So the given condition is y0 is equals to 0, this one. So what does it mean? X is equals to 0, y is equals to 0. Okay? This one, x is equals to 0, y is equals to 0. So substitute where you want to substitute this condition, up into here. Okay? So you will have a e negative 1 over 2 times 0 plus b e negative 2 times 0 is equals to 0. So simplify this equation will give you a plus b is equals to 0. So this is your first equation. Okay, because exponent 0 is equals to 1. So the second condition is, where is it? Okay, y prime 0 is equals to 1. Okay, so y prime 0 is equals to 1. What does it mean? Sorry, y plus 0 is equals to 1. So x is equals to 0, y is equals to, y prime is equals to 1. So you have to substitute the condition into this equation. Okay, so we'll give you, so let's label it first so that you don't get confused. So this is your first equation. Okay, so when you substitute x equals to 0, y prime is equals to 1 into this equation, you will have negative 1 over 2a minus 2b is equals to 1. This is equation 2. Okay, this one. So now you have to find the value of a and b. Okay, so you can either use substitution method or elimination method, but the simplest is by using calculator. Okay, so how are you going to key in this equation into your calculator? So again, you have to find mode equation, equation number 1. Okay, now you involve with, now you are dealing with unknown, isn't it? Because this is unknown and this is unknown. Okay, so you have two unknown, so choose number 2. Okay, so now you have to key in. So this one will represent your a1, b1, c1. Okay, same goes for this one, a2, b2, c2. You don't have to bring what you have on your right hand side to your left hand side. No, just take this value as c1 and this value as c2. Okay, so let's do it. So a1 is equals to 1, b1 is equals to 1, c1 is equals to 0. Another one is a2 is equals to negative 1 over 2, b2 is equals to negative 2, and c2 is equals to 1. So you will have your e. So the first value, this one here, you have x. Okay, but remember, now we're dealing with a and b. Okay, so the first value will be the value of a, and the second value will be the value for b. Okay, so therefore you will have your a is equals to 2 over 3, and your b is equals to negative 2 over 3. Okay, so what are you going to do with these two values? Yes, you have to substitute these value into your general solution. Okay, this is general solution. When you substitute the value of a and b, this solution will become particular solution. Okay, remember I told you before this, we discussed in the previous class, you have general solution, you have particular solution. So this is your general solution. If you are given a condition, so you have to find the value of A and B, substitute into here, therefore we call it particular solution. So substitute these two values into this one will give you y is equals to 2 over 3 e negative 1 over 2x minus 2 over 3 e negative 2x. Okay, so if you want to simplify this solution, so you can factorize this one. So therefore, you will have y is equals to 2 over 3 exponent negative 1 over 2x minus exponent negative 2x. That's it. Okay, so this is your particular solution. Okay, so this is the example on how to solve first case problem. Okay, why I call it first case? Because you have two different videos. So now let's try to solve. Take a look. We take a look at second case example. Okay, so let's say you have this one. Okay, this one. 9y double prime minus 6y prime plus y is equals to 0. Okay, so we do it quickly. So the first step, you express this one into characteristic equation. So you have 9m squared minus 6m plus 1 is equals to 0. So get the value of m. So key in the calculator equation. You agree to. So your A is equals to 9, your B is equals to negative 6, and your C is equals to 1. So we give you your M is equals to 1 over 3. Okay, so as you can see here, you just have one value of M. Okay, so which means that M1 is equals to M2. Okay, so your M1 is equals to M2, which is 1 over 3. So this is case 2. Okay, so take a look back at this one. So case 2, what is your general solution? This one. Okay, so therefore your y is equals to a plus bx e 1 over 3x. Okay, since substitute the value of m. So this is your general solution. Okay, again let's consider if this one you are given an initial condition which is y0 is equals to 6 and another one is y prime 0 is equals to 9. Okay, so as I told you before, you have to differentiate to get the y prime before you can use this condition. But you have a problem here. Why? You cannot differentiate this one directly because you have two different functions. This one is your polynomial and another one is exponential. Okay, remember when you have a multiplication of two functions uv, so you have to use product rule, okay, to get your y prime, which is given uv prime plus v u prime. Okay, so for this case, define your u and v. You can either choose this one as u and also this one as u. It's up to you. Okay, so now I'm using the first expression to be a u. So therefore you will have u is equals to a plus bx. So differentiate this one will give you b. Okay, and your v is equals to exponent 1 over 3x. So differentiate this one will give you, differentiate exponent, you will have exponent, and differentiate the power here will give you 1 over 3. Okay, so therefore your y prime is equals to uv prime plus vu prime. So you will have 1 over 3 a plus bx e 1 over 3x plus b e 1 over 3x. So this is your y prime. Okay, so again this is your y and this is your y prime. Okay, so now you can substitute the conditions given to you. Y0 is equals to 6 here, so substitute into here. Another one, y prime 0 is equals to 9, this one here, so you can use the second equation. So this one will give you, so the first one, y0 is equals to 6, so you will have x is equals to 0, y is equals to 6, right? So you will have a plus b 0 exponent 1 over 3 by 0 is equals to 6. Okay? So simplify this one will give you a is equals to 6. Okay? So the next condition is y prime 0 is equals to 9. So substitute this condition into the second equation. So you will have 1 over 3 a plus b x equals to 0 exponent 1 over 3 times 0 plus b exponent 1 over 3 times 0 is equals to 9. When you simplify this one, you will have 1 over 3 a, because this one 0, so you can cancel out, e0 is equals to 1, plus b is equals to 9. Okay, so substitute the value of a here into this one, so you can find the value of b, implies that your b is equals to 7. Okay, or you can use again, use your calculator to get the value of e and b. So this is the first equation, this is the second equation. Or you just substitute a equals to 6 into this one, so simplify this equation and get the value of get the value of b is equals to 7. So now you have your a equals to 6, b equals to 7, so therefore your particular solution will be y is equals to 6 plus 7x e 1 over 3x. Okay, you substitute into this one, okay, not this one. Okay, your general, which is y. So we are done with one example from case 1, one example for case 2. So now last one, case 3. Okay, we do it quick. Okay, so let's consider this example. 2y double prime minus 2y prime plus y is equals to 0. Okay, and you're given an initial condition y0 is equals to 1, another one is y prime 0 is equals to 1. Okay, so change this one into characteristic equation will give you 2x squared minus 2m plus 1 is equals to 0. Okay, when you use calculator to find the value of m, as you can see here, your a is equals to 2, your b is equals to negative 2, and your c is equals to 1. Okay, although you have your x1, you are given the value for x1 which is 1 over 2, but take a look at this part. When you have this one, r here, it's mean you involved with a complex root. Remember, during your max one, how to find the complex root for m. Negative b plus minus square root b squared minus 4ac over 2a. Okay? You can use this formula to get the value of m. Or you can take the value from the calculator, but you have to know which one is your alpha and which one is your beta. Why? Because as we discussed earlier, I already discussed to you case 1, case 2, case 3, right? Okay, this one here. Okay, so when you involve with a complex root, so you have to know what is your alpha and beta. So now the calculator will give you the first value, which is 0.5, so which is 1 over 2. Okay, so your m is equals to alpha plus minus beta I. So this is the general one. So what you have, your alpha is equals to 1 over 2 plus minus. So now how are you going to get the imaginary part? So this is the real part, right? So how are you going to get the imaginary part? So you just press shift answer, where you have another one is I here. So therefore you know that your beta is equals to 1 over 2. Okay. So now by referring to this one, you know that your alpha is equals to 1 over 2, your beta is equals to 1 over 2. Okay. So what is your general solution? Again, you can see here. Y equals to exponent alpha x e cos beta x plus b sin beta x. So your general solution now will become y is equals to exponent 1 over 2x e cos 1 over 2x plus b sin 1 over 2x. This one here. Okay. Well, this is your y. So now, again here you have to differentiate. Okay. Try to do on your own to proceed with this one. But remember, you cannot differentiate this one directly. Why? Because you have two different functions. The first one is exponential function and the second one is trigonometric function. Okay, I don't advise you to expand this expression. Why? Because when you expand this one, you still have to use product rule, isn't it? Okay, so you have to do two product rule. So don't waste your time. You just use this one as u, and the whole function here will be your v. Okay, so your u is equals to exponent 1 over 2x. So u prime is equals to 1 over 2 exponent 1 over 2x. So now this is your v. A cos 1 over 2x plus b sine 1 over 2x. So differentiate this one first, and differentiate this one. Okay, because here you have an operation here, don't worry. So you differentiate single term, the first term and the second term. Okay, so differentiate the first part will give you, so a is a constant, so differentiate cos will give you negative sine 1 over 2x. So this is the argument. right? So differentiate 1 over 2x will give you 1 over 2 plus b, so differentiate sign will give you cos, the argument is 1 over 2x, so differentiate 1 over 2x will give you 1 over 2, so again times by 1 over 2. So therefore your v prime is equals to, so be careful, 1 over 2 here you cannot multiply with the argument here, okay? So you have to bring this one to the front. So you will have negative 1 over 2a sine 1 over 2x plus 1 over 2b cos 1 over 2x. Okay, so I already guide you with this product rule. So now continue on your own, get the y prime, okay, and substitute the conditions given to you, this one here, into the first equation, and the second condition here, y prime 0 is equals to 1, into this one. Okay, get the value of a and b and find the particular solution. Okay, so I give you the final answer, so you try on your own. You should get this one, y equals to exponent 1 over 2x cos 1 over 2x plus sine 1 over 2x. So this is the final answer. So try to continue on your own until you get this one. Okay, so I see you in the next video on how to solve non-homogeneous equation with constant coefficient. Okay, that's all. Thank you.